Hello everyone, again, my name is Fuge. I'm the data science lead in the RapidCanvas. Today I'm going to show you a demo that which is like a Kaggle, a data set from Kaggle, which is the telecom data set. This is something you can get from the public, right? But what I presented to you today will apply to your business. If you gave us the data, we can access to your data. We will build probably much more like a sophisticated system using your data, because data is like food, right? Without much like material, there's not much you can do. But we will try our best to present the idea. We try to the strategy. We try to and technology we have to with you guys. So first of all, this is like a churn in the telecom industry. Telecom is kind of following this subscription model, right? Either you subscribe to their monthly service or you quit. If you quit, that is kind of defined as a churn. I think for you as a SaaS platform, that logic is probably similar. Your customer keep paying you like a monthly bill, and they are your customer. But once they quit, they stop paying. That is like when they try to try to switch to another vendor, or they just cancel the subscription, which we want to prevent, right? We want to prevent the churn. We want to define the churn and how try to have this actionable insights on how to deal with that. So first of all, we have 5 sections here: the EDA, exploratory data analysis, feature engineering, and followed by the model performance and model prediction, and the last one is customer segmentation. So we using this data, we can do all sorts of stuff, right? Starting with exploratory data analysis. Here you have the telecom churn data, basically give you like what generally the data look like. For example, the data has 7,000 customers with 21 columns, and you can see these are the a very nice piece of data with some combination of categorical columns and a numerical column. And what you are trying to predict is this churn label, right? Churn label is basically yes or no. So this can be a binary classification problems. So we're going to solve. So for churn distribution, we will have 26% of the people who are churn. So so we're going to try to predict who is going to churn. And this is a data definition. So basically, we have all this customer service booked. So whether this customer has such kind of service, like is this customer has a phone, is that customer has internet or online security backup, or sometimes do they have streamlined TV, or do you have streaming movies, or the customer has some customer general basic information like what is the tenure of his customer. This is important because, of course, it's a common sense, right? The longer the customer stay with you, the less likely he's going to churn. When it's more loyal customer, you try to worry less about that. So the contract, the paperless billing, what is the payment method, what is the monthly charges versus total charges. Total charges it's like a LTV, right? Lifetime customer values. So customer demographic info, including the ID, the gender, is that a senior citizen or not? Is this customer has a partner or not? Is this customer has dependents or not? So so very basic demographic info. And our target variable is churn, right? Whether this customer is going to churn or not. But this is tricky because in Kaggle, they predefine that churn for you. So this is like, they already tell you what's going to be the target variable. But oftentimes in real life, nobody's going to tell you whether it's what is the definition of churn. I think for subscription type of business, it's easy. It's whether the customer pay monthly or not. But for the merchant like e-commerce, that's becoming complicated, much more complicated. You have to be able to define the customer churn. For example, if I'm on Amazon, right? If I don't buy things from Amazon for 3 months, shall I be defined as a churn customer? Maybe, right? You can't say just. You have to be able to experiment that concept before just defining a churn. That is a difficult part. So we have some like general EDA stats, like distribution, and of course, this is a basic distribution between the for this particular label column, right? And this is this column versus churn, right? You can say tenure versus churn. You can say definitely the longer the tenure is, the less likely it's going to be churn. But the shorter the tenure, the shorter time that the customer stay with you, he or she may be more likely to churn. This is like a tenure, and you can switch a little bit So you have contract. Is this have a contract or not? Is a 2-year contract, 1-year contract, or month to month, right? Of course, month to month has a much higher probability of churn, right? And because most of the people are actually month to month, it's kind of not good, right? You want them to stay longer with you, so you want them to sign a longer contract with you. So you can switch between paperless billing, but basically it goes through these. And you also have these like checking the service booked. This is one driver because customer choose, for example, this is online security. If a customer choose to have a online security system with their so they are less likely to churn. If they don't have this feature, they are more likely to churn. This is online security or technical support, right? If they have technical support, they are less likely to churn. Versus if they don't have, it is more likely to churn. And for demographics, you probably have some like genders, senior citizen. Genders are probably equal, so there's no like yes or no for like which one is more likely or not for gender. Senior citizen seems like it's interesting. So if you are a senior citizen, you are more likely to churn, which is weird. We probably will have some like explanation. If you have a partner, you are less likely to churn, right? If you have a dependent, right, your kids likes to watch TV, so you are less likely to churn. This is like checking the numerical feature. We have 3 numerical feature. We have tenure, we have monthly charges, we have total charges. So we have this like tenure, right? For example, like I said, the longer you stay, like 40 months in average, in the medium, and you are less likely to churn. Versus you stay shorter time as a customer, you are more likely to churn. And this is breakdown by tenure and breakdown by categorical feature. You can probably select like billing or paperless billing. So which one under this bucket, I'm gonna say yes for paperless billing and no for paperless billing. I think the trend stays the same, right? You can say this is like senior citizen, right? You can also have that. So this is a nice box plot to help you understand the data. So after I have a general idea of the data, we just move on to the feature engineering, where we have to this is because we're going to try to build a prediction pipeline. So here we just try to keep it simple, right? For feature engineering, what we have done is 3 steps: data processing, pre-processing, where we have dropped the customer ID, which is like ID, like in customer ID, the like unique identifier. Usually you don't use that for machine learning, and you impute missing values with a median, right? This is another thing. And you standardize the categorical features, make them 0 or 1, because they are yes or no, right? You can standardize them like yes means 1, no means 0. You drop highly correlable features, and this is what we have impute these like missing values with median value on that column, and we have done some one-hot encoding on these like yes or no problem, right? Either you are a male or female, are you a citizen or not, are you a partner or not, do you have dependents or not, do you have online security or not. This is like one-hot encoding. And we also have feature selection, where we dropped the highly correlable columns. This is important because this will prevent overfitting. In a machine learning world, you like a clean data, they are trying to be independent of each other, right? You don't want these highly correlable features get into your machine learning. That will not only affecting your overfitting problems, and it will just you don't have a good sense of how to explain that, right? Because multiple similar feature will have interact to each other, interference with each other. So after that, we're just using this AutoML library to do this model machine learning model building. So we have tested 5 different models, like gradient boost trees and XGBoost. So we have the best model we have is this ID called GBM1. So I'm going to present you some like a model summary, the model performance explanation, and we're going to derive some actionable insights from these results. And you can see the best model we have is this GBM tree. And using this model, we have this model performance, which is like confusion matrix. If you are a data science person, this is like the number one thing you look at when you evaluate the model, right? You have this true negative, true false, true positive, and false positive, false negative, and you are looking at AUC here. So we have 85% accuracy here. So which is you look at AUC, right? Error under curve. This is the the important metric you are looking at this model. And this is an important chart, which is like an explanation of what is a key driver versus what is not a key driver. So as you can see from this model, you have the ranking from top to bottom. Let me zoom in a little bit. You will see better. So this is the shape summary of this model. And this model is our best model using the AutoML library. And you can see the biggest driver is like contract month to month. And if you look at the red, which means it is a positive driver. So it is a red to the left, which means the red is to the left, which means the red and blue, they differentiate very well. So this is like binary, almost like a binary problem. Like bipolar, it's like your red is driving your churn, like very, very obviously driving your churn very strongly. It's a very strong driver. So think about that. So if you're a month-to-month subscriber, it's very easy to quit, right? You don't get any punish. Like I'm renting a house, I'm renting this service like month to month. So it's very easy for me to switch. But if you are a longer tenure, right? If you are tenure is like I'm staying here for quite a while. I'm gonna sign a 2-year contract. So if I have a tenure, it's like opposite direction. The red is to your left, which means it is a negative driver, right? Tenure is like the longer the tenure, the less likely to churn, which makes sense, right? And you have fiber optic, online security, monthly charges. These are all positive drivers. Technical support. So if I don't have technical support, I'm more likely to churn. If I have electronic check, I'm more likely to churn. If you have a total charges, I think total charges co-correlated with tenure. The longer you stay, the higher the value you have, and it is less likely to churn. So everything makes sense here, right? Everything seems to make sense. So let's summarize what we have seen so far. So customer with month-to-month contract is very likely to churn. So in order to deal with this problem, we have actionable insights, which means we're going to promote long-term contract incentives to customer. And customer have longer tenure are less likely to churn. So actionable insights here is try to reward customer with longer tenure and membership and loyalty program. Customer with fiber optic internet service are likely to churn. I think maybe they have a better option here, but maybe this is worth investigate if it is real, if it is a real life, right? Customer without online security are likely to churn. Maybe we can promote online security option to bundle with the plan, right? So they can have the free online security, like maybe just included, right? Higher monthly charges are likely to churn. Again, we try to promote a longer contract with lower monthly charges. Customer with electronic checks, so we want to improve the payment system. A customer with higher total charges are less likely to churn. Try to reward the high-value customer and keep them longer. So customer with no paperless billing are less likely to churn. So keep the no paperless billing option open. Improve the experience of the paperless billing. Customer with 1-year contract are likely to churn than 2-year contract, relatively speaking, right? So we try to promote customer with 2-year instead of 1. We give them enough incentives. I think this one is like telecom churn is not related to your business, but for your data. Once I have your data, I'm gonna generate the same interpretation and actionable insights for you guys. So ROC curve, precision recall, false positive. If you are not data science guy, I don't want to waste time interpreting this. But basically, this is like how evaluate the accuracy of our model, and you can change the threshold. It is usually used for fraud detection, right? So this is basically like this general output from a machine learning model. Lift and gain model for business. This is important because this is like when you try to invest into this, right? This is basically tell you will have the biggest bang for your buck. So remember we have 7,000 customers, which breaks into like 10 folds, right? Each one will have 700 pieces. But we are focused on the population, the cohort with the highest probability of churn, and we're getting like 3 times lift, and we are capturing 31% of the overall churn customer by only focusing on this like top 10% with highest probability. So this give you like a big bang for your buck. If you want to spend money, try to promote or try to marketing. So this is basically indicate that you will have 3 times lift to target this customer correctly and promote this customer and be using your marketing budget very efficiently, right? Your capital efficiency will be high. You're targeting this like very accurately defined this like a customer. So this is actually this is where you gain and lift your investment. So this is like for the model performance. After model, we have this model prediction. So this one is interesting, where this is a new data set, right? Well, after we build the model and you try to deploy the model into production, new customer coming in. So this is like a real deal for the future. I don't know anything about this user. I'm just fake. I know because I just say there's a churn label. This is like I pretend I don't know this, right? This is a new people. So I'm using this. I'm trying to select a new customer, and I will see what he behaved. So this is his records. His records are these, right? So he has 41 tenure, like monthly charges $83. And let's see, our prediction result is gonna interpret in here, right? You can see the driver here is like, okay, for this particular customer, I'm just select a random customer. He has month-to-month contract. He's likely to churn. He's not a senior citizen. He has fiber optics and all these like small features we can explain which one is the positive driver, which is one is a negative driver. And I think the negative driver he's a 41 months of tenure. He's like a loyal customer. Why he's churning? Because he has month to month. So let's just say how we can deal with this, right? So we know this is a fact and we correctly predict that, but how can we use this what if analysis try to do something with that? So say for example, I want this customer to be like a contract from month to month to yearly, right? I'm gonna switch this to, this is what if, right? I'm gonna click this and this will update, right? If you switch from month to month, look at what this is. Remember the chart you just said? And month to month, if it is yes, it is a big positive driver for churn. But you switch that, everything is the same. You only just turning one knob, which switch from month to month to yearly. So it becomes, prediction becomes no. This customer will not churn. So this is like common sense, right? Let's go back to what we have here. And let's try to say, okay, month to month, that's good, but not good enough. How about we reduce his monthly charges? Give him like 2-year contract, reduce his monthly charges to $60, right? Give you a nice discount and say again here. Let me make this larger, and you can say, okay, I'm still month to month, but I'm giving you like give you a discount. So so monthly charges become a negative driver for churn. So if you give him like enough incentive, like somewhere between $60 to $80, like $70, right? I'm gonna give you some discount and sign a longer contract. You are likely to churn less. So this is like logic. Okay, although this is telecom churn, but for your the logic is the same. When for your model, I'm gonna build exactly the same thing for you. And the last part is segmentation. So we're going to separate this customer and we're going to group them into different buckets, try to deal with them different, try to describe them. So first of all, we have the direct churn risk, try to just break them into different by risk, right? You can break this customer by risk. So low risk is like where we predict a lower probability of churn, high, medium risk, and high risk, and very high risk. So very high risk means you have 80% probability of churn. You'd better do something with that. And the actionable insights here is that we promote customer with both high risk of churn and high values. But because you don't want to deal with like low value customer, even his churn, fine. I don't lose much because I'm losing lots of values for this high value customer. This is like customer value versus probability of churn. So this is where you define this high risk and very high risk. And you are going to define this like a customer value is $4,000, $8,000. They're going to churn. You cannot lose them, right? They are very important people. So you are going to deal with them. Right? Try to give him them lots of nice incentives. So this is like for this churn risk. And also this one is for K-means clustering. So this is interesting because we have this automated workflow that try to define different churn. Like we try to detect what is the best K. So how much group you want to group this customer into, right? Here I'm just showing you an example of 7 groups. Although this is, let's say 5, this is probably another version. I have an earlier version. So we have 7 groups, and these groups can be explained using these features. You can say, you probably want to rotate your head a little bit. That is like a tenure, monthly charge. So we're using these features try to describe this customer's behavior. So you have these dimensions like 1, 2, 3, 4, 5. It's like over 15 dimensions. We try to use these 15 dimensions. This is exactly what we use for the machine learning. We use this feature try to break this customer into different buckets. So this is how we describe, like the red example, right? Number 3, I think clustering like the number 3, you can see this is a high value customer. stay. I think the y-axis here is the z-score. So you can say for this red, for this number 3, this is very high value customers. Stay very long. Monthly total charges very high, and they have all the yes for all these like services. So this is a very nice high value customer. For example, I'm trying to we are gonna try to write lots of interpretation out of this, right? This is just an example here. So that's all. That's all for this dashboard. And sorry, we're almost running out of time. I'm gonna show you our platform. Our platform is like the UI is like this, where you get into this RapidCanvas platform, and you click this churn. And this is where you start with the train and test. Test is something you don't know, and you build this entire workflow. This is a very simplified workflow. Basically, you have this train data to the preparation, data preparation. After preparation, you have this like prepared data set goes into feature engineering. So circle here means a process, right? You process is like you have the recipe, and you can add some templates into that recipe. That becomes a process. So feature engineering has several steps. Like I said, you have data processing, one-hot encoding, feature selection. They can be grouped into this circle, and you have this train with features ready to go. This is like machine learning ready data set. This is your data set. This will goes to the machine learning process, and will generate some output. This is the dashboard I show you in here, as this is the same dashboard, and this is the train with predictions. And after that, we're gonna use our data feature and artifact system. We're gonna save this model and use this for the test. So test is the data it's a new data, which is like you never know. You hold our data set, and you have this data preparation using the same process, and you will have this feature engineering goes into the feature, the test data with features, and you're gonna go through this deployment phase. Basically, you load what the model like this one shows, right? You load the model and you try to predict, and then you are gonna generate a bunch of what if analysis there. So basically, that concludes to the demo.